Alright, what's good, Facebook family and everybody else out there in the internet world? This is your boy Jay Veal, CEO of INC Tutoring. Ready to kind of give you a little bit more of a snippet video of discriminants. Not discrimination, but discriminants, alright, in the mathematical sense in quadratics. So, basically what a discriminant is a portion of the quadratic formula. Remember in the previous video, we discussed that the quadratic formula was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, now the discriminant portion is only the b squared minus 4ac part. So I'm going to circle this part right here. Alright, and that's going to be my discriminant portion. Okay, so I'm going to label that discriminant right here. Okay, so b squared minus 4ac, I'm going to cut that out, is my discriminant. Okay, so b squared minus 4ac is my discriminant. What the discriminant tells you is how many solutions, or determines the number and type of roots or solutions that the quadratic equation has. So there's a few different qualifications to this. If b squared minus 4ac is greater than 0 and is a perfect square, alright, and what I mean by perfect square, not talking about the squares that some of y'all friends are, you know what I mean, but the square of a number or square root. Like for example, 16 has a square root evenly of 4. 64 has a square root evenly of 8. Let me see. 100 is the square root of 100 is 10. So the perfect square, alright, is 100. The perfect square is 64. The perfect square is 16. The perfect square is 4. Those are perfect squares. Now, if it's greater than 0 and is a perfect square, then it has two real rational roots. What that means is that it actually crosses the x-axis in two different spots. One's here and one's there. Okay? Any questions so far? Alright. Once again, if you have any questions, you can text me 817-300-9112 or email me j.veal@inctutoring.com or hit us up on Facebook at INC Tutoring. I mean www.facebook.com/INC Tutoring, and on Twitter at INC Tutoring. So the next part is if b squared minus 4ac is greater than 0, but b squared minus 4ac is not a perfect square, then you have two real irrational roots. And an irrational is going to mean that it's going to be a fractional. It's going to be a decimal. Excuse me. It's going to be a decimal. The rational can be a fraction. The irrational is going to be a decimal. Again, it still crosses two different points. It's just going to cross at a decimal, like 5.238 and negative 5.238 or something like that. It's going to be a decimal involved. But there are two real rational or irrational roots as your answer. Now, if b squared minus 4ac equals 0 exactly, you have one real rational root. What that normally means is that the graph kisses the x-axis at one spot. It's called a double root. Alright, so it's called a double root. Graph looks like this. It touches the x-axis at exactly one spot and then comes back up. And that's my little dot right there. Alright, so it hits it at one spot only right there on that line on the x-axis. Of course, I'm going to label those as our axes. Alright? Now, the last sentence is that what if all of a sudden I have a b squared minus 4ac and it's less than 0? Alright, well, we're going to take care of that. Okay? Those, my friend, are what we call complex roots. Okay? So if b squared minus 4ac is less than 0, you have two complex roots. Complex roots are imaginary numbers, which are represented by the letter I. Okay, and I, the square root of negative 1 is I, by the way, and I squared equals negative 1 if you did not remember that. So two complex roots. What that normally means is that there's no solution. It sits off in one of the quadrants, quadrant 1, 2, 3, or 4, and doesn't cross the x-axis. If it doesn't cross the x-axis, that means there's no solution to it, point blank. So, as a quick example to this, let's look at a little example. 9x squared minus 12x plus 4. Alright. First thing I'm going to do is label my A, B, and C. Okay? In this case, A, B, and C. A equals 9, B equals negative 12, and C equals 4. Okay? I'm going to plug it in like Glade, right? So now, I'm going to go ahead and do B squared minus 4AC. Alright, arrow that over to negative 12 squared minus 4 times 9 times 4. Alright, I get 36 times 4, which is basically 144 again. So 144 minus 144 equals 0. Uh-oh, so that's 0 as my discriminant. How many solutions do I have? Well, if it equals 0 as we go up here, if it equals 0, we know that it has one real rational root. So this answer is one real rational root, which means it kisses the graph and is a double root. Okay? That's a quick example of one of the problems. Alright? And you would do the same thing for other ones. Alright? So for example, if it's negative, on this one I'm going to do 2x squared minus 16x plus 33 equals 0. A is here, B is here, and C is there as my substitutions. And then I plug it in like Glade says. So B squared minus 4AC equals 16 squared minus 4 times 2 times 33. Alright, once I get that done, I evaluate at 256 minus 264. It gives me negative 8. Since the answer in discriminant is negative, there are no solutions that are real. Alright, both of these is two complex roots. That means that it sits off in a quadrant somewhere, and the answer involves an I of some sort. Okay? So those are some examples. Any questions, hit us up. Alright, visit the website, www.inctutoring.com. You can see our Facebook feed on there as well. Alright, y'all. Thanks for tuning in. Make sure you have a blessed day. Holla.